Hello everyone. Today is gonna be quick live with me carry on working on my new project. So yeah, I've made live stream about 2 days ago. Did some changes. So today I'm just gonna carry on with the project. So if you're interested what I'm working on, just gonna quickly show you. So this is the new mobile game, and this is gonna be match 3 game. I'm just based all of the implementation on the Word Spy game, which I made tutorial on the YouTube as well, so you can check it out if you like. So this is basically currently I have the grid with different pictures, and on last live stream I've done the proper implementation of the selection and then removal of the squares. So now you can select the square with the same picture, and then you can select as many as you like, and once you select it, remove it, those squares will be removed and everything will be pushed down. So today I will want to implement respawning of the squares and maybe add some object pooling to this. Not sure if I'll be able to fully complete that because the stream is not going to be very long. It's going to be about an hour. So I will try to tidy up some code because there is a lot of things which is actually from the Word Spy, even the naming of the classes and the variable, which is quite messy at the moment. So just need to do that. And also I'm doing this on the Mac, which is fairly new for me. So might be a bit slowness with me navigating the system. Is still getting used to that. So yeah, the first thing probably I will want to find the position of the column where the square was removed. So I need to find those 4 position in this case. So I need to know how many rows I have in the grid. So let's quickly see if I can figure out how to do this. This is old project, so I'm not can't remember everything, but have idea where things are, I think. Yeah, so I've just introduced the move data, which is for every single square we have the square index, which is the square above, and then target position, which is the target position where the specific square will be moved to, and the target square index, which is the square we removed and how many moves. So that's as the data, and I'm populating that every time I select more than 3 squares. Right, so this is the remove grid square class function, which I've done last time. And can I make it bigger? So yeah, the adjusting the windows for on Mac is not very good. I'm using the custom tool, the magnet, to actually stack the two windows on the screen, but it's not as good as on the Windows. So this is one thing which is a bit frustrated. Okay, so first of all, I'm gonna actually make some tidy up some bits. So the normal letter data, I think this is the alphabet data, which was the prefab. Yeah. So in my resource folder, I have the prefabs, and then I have the grid square, which is the square. If I remember correctly, there was puzzles. No. Prefabs, searching words. Okay, so that's this. Sources. Yeah, I have the alphabet data, which currently holding the sprite of the letter, and I have the normal, plain, and then wrong. So I'm just replacing the sprites on the Word Spy, so we don't need that actually now. So game level data, which is the the data for the puzzles, right? And we have a puzzles there. And I'm gonna use this custom editor, I think. Because what's gonna happen is I'm gonna have this custom editor, which will reflect the grid on the game. And then I'm gonna add I'm gonna populate this one with the power-ups, the additional like items at the bottom. That's gonna be the bomb, lightning and stuff like that. And then based on this data, I'm gonna basically, when you remove the squares from that position, then I'm gonna award with the bomb and things like that. And I might actually add it randomly, I'm not sure yet, but this is just the rough idea how I'm gonna do that. So there is alphabet data, current game data. Okay, and right, so this is the data, but this is not wanted to get this grid square prefab. Right, so this is the grid square data. So in the grid square data, currently I have the enum set for all of the pictures I'm using, and this is actually scriptable object. If I select board data, okay. Okay, so this is the board data. Okay, so the board data is the one with the custom editor. Okay, so the board data is scriptable object, that's right. So we have this row. So, okay. Okay, a lot of comments. So this clear out. So the word is basically the searching word, which is the so we don't need this class for the searching word because we're not using this at all. There's gonna be a lot of refactoring for this project. It's a lot of stuff which I don't need, and okay. So first of all, what I wanted to do, I wanted to find the positions of the squares. So if I remove 3 squares, which I don't have, 3 squares with the same picture, so for example this, I need to get the index 0 and 1 for the column. So the way I'm gonna do this is in the word checker we have this square selected and the assign point is equal to 0. This is for the first selection, so this is when I select the first square. First square selected, and this is basically every other square. So, and we have the assign point. So at the assign points is basically how many squares we have selected, and I need to get the from the board data, no, from the word grid, I need to get how many columns and how many rows we have for the current board. So I think there should already be the data to pass to that, because we spawning the grid somehow. So when spawn the grid, I have this row. So this is the grid square. No, the spawn the grid is just creating the objects, but we need to actually see where the okay, so here's where I set the position for every single square after its spawn, and I have this column number and then row number. So if I expose this, that should be good enough, I think, because what it will do, okay, let's actually debug it to just double check if I can use this. Right, so if I start, the row number is 0, and if I go skip to here, run to here, it's weird on the Mac. Okay, so the row number is 4, and then the column number is 3. So I think the column numbers start from 0, right? So this is the column, and this is the row, I think. So position X, yes, that's right. So we are interested about position now. So I need this row number. Now I need the column number. So I need to find this column number. So the total columns will be, okay, so let's stop that. And I gonna get this. Total columns, and then total rows. Okay, so the total columns will be so I can actually replace that with total columns total rows. Okay, so that's gonna be here, and the rows. So theoretically I should have that data available for this class. So this class is created every time we're entering the game scene, so that should be reset anyway, because it's just gonna spawn the new instance. So if I go right at the top, I just need to access that. So right. Get total column counts, and then we return the total columns. So this is this gray text you see is basically the text generated by the GitHub Copilot. I have actually trying out this solution, not using this very often, but as you see in this regard, it's just automatically predicted what I wanted to type. So it's basically what I need to type now is a tab. This is exactly what I wanted, another function. So it's very helpful and saving you time sometimes. Yeah, so that's perfect. And then I can get the word grid. So I need to find the instance for the word grid in this class, which I already have. And then when we select, so the flow of the game will be we selecting the square, then we checking the word, which obviously is not going to be check word. This function is useless at the moment, because previously we had this function to check if we selected the specific word which we were searching for. And now we're gonna call this check selected selection, maybe. Check selection. Okay, so that's gonna be okay. Okay, so later on I'm gonna add some more implementation, and maybe I will. So this to do. So this macro, if you're using Rider, this to do thing is basically, if you don't know about, there is Windows somewhere to display the to do macro. So inside the edit, I think there is Windows. Tool window, to do macro. To do. So, and where is that? So as you see, I have this to do. Every time I put the macro to do, is just adding this to do thing. So you can go later on. You can go through the list and see what else you have to do, and you're just not forgetting. And you can basically get the to do for the solution, for the file, and for the scope, which is the project files, or open files, or can we have the project file? So this is basically the to do thing. It's very useful. Sometimes it's is worth to create something like that to not forget stuff. So when we select the square, we invoking onCorrect word, which is going to the searching word, and then the grid square. And inside the grid square, what we do nothing. Okay. So in the word checker, this can be actually commented out at the moment because it doesn't do anything. And then checkboard completed. I think this is what so this is here. Okay, so the clear selection is actually triggering the behavior to remove the squares. Or remove grid square. So the remove grid square is in the word grid. So this is where we're actually removing that, and is also here. Right, so it's just indicating that this square is removed. Okay, so in the word checker, I will, after this remove grid square, what I will do, I will add another action. Public static, and that's going to be called spawn missing squares. Creating a new square. Okay, and then we're gonna subscribe to this inside the word checker. Actually, in the word checker, after we remove this, we will call the game events dot spawn missing square, and we're gonna just invoke this and then it would be good actually to add on which column and which row we have removed that. So we need to find the row and the column here. So before we do this, I will need to get the information about the column and the row. Okay, so what I will do is right at the top I will get the structure. Struct and that's gonna be respawn data, and then what I need to do is I need to get the public int and column index and how many squares we want to spawn in that column, a square number. Okay, so this respawn data, this is basically going to keep the information, and what I need to do, I need to get the list of this, so private list of respawn data, and I will call it respawn data, exactly that. And I will use this respawn data to basically get the index for the columns. So in here, what I will do, I will first of all clear the respawn data, so make sure there's nothing there. And as you see, this AI also generated the code for me, which is predicted what I wanted to do. It's very handy, but it's not exactly right, so I just gonna modify this. So the square list is holding the list of the selected squares, whatever we select. So for each selected square, I need to find which column is it from. So I have the total number of squares per grid. So where is that word grid? And I need to get the total number of squares. So the board is okay, so the board is the arrays of the rows, so the size of the board is how many columns we have, and total size okay, so the board data, it has the column and the rows, right? So the board data can be taken from current game data, right? Okay, so we can do that. World grid dot current game data dot board. Selected board data, is that current game data? So we have a board. So we have a board. Okay, so select data board dot column dot columns, and we can get the same for the rows. Okay, so var so total columns, total rows, and now we need to know how many squares we have. So okay, total squares, and what we want to do, we need to know how many squares we have per column. So we're gonna divide the var square per columns, square square per column, total square by total columns, right? So we're gonna divide the total number of squares by the total columns, so we know how many squares we have per columns, and our squares starting from index 0, so we can predict which column number is for the removed square. So the selected square is basically the square we have selected and it's gonna be removed, and we have the square index, so we can actually predict from which column this square is. So there is a clever way to do that, but just thinking how we can work it out, because we have square per columns. So okay, so we can do like that for and we need to loop through the total columns, and now let's make it var and make it, and now what we want to do is we want to check if okay, we want to loop starting from 1, and we want to make it equal, because if we multiply by 0 we're gonna always have 0, so if the square count per column times I is less or equal square index, that means we have found the column. So we can then break from here and we can assign our column -1. That's right. So we can then create our data, which we can populate our data, which is the respawn data dot add, and then we can get the no, we can do that. RD will be equal to new respawn what is called respawn data. Respawn data, and that's gonna be this. So we can actually simplify this by using .bit. Add right, and then I don't think we need to specify the type, do we? No, we have. Okay. So we can create the respawn data this way. Let's make it like that. So the square index, so the column index, so square number is the square index, so that's going to be the square index, and the column index will be I minus 1, because we're starting the columns from 0, so, and we're looping through from 1. And then once we done this, we can call this event, and we can actually pass our data, our respawn data, and we need to actually look for list of the respawn data. Yeah, so we want to pass that list to this event, and now I think we need to make this structure serialized. That's right. Okay, and then respawn data is here, so we can invoke that and we can pass that in respawn data. Okay, so we have, once we remove the squares, we're gonna respawn the missing squares. So if I delete, does it work? No, it's just crashed, I think. So if I remove 3 squares to 3, we should have it. Okay. So now we need to respawn it. So in the game event, in the word grid, on enable, I gonna do the game events dot. That's right, and I will do that here. And then let's create this method. Let's move this method down below. And now we have the list of the objects. Now we need to find the position from the column. So in the respawn data, I think it would be good to store the position of the, we need to basically find the position of every single square at the top from the first row. So I think we have this current game data, selected board data dot board, and then we can have this. So I think this is the array, is it? That's right. So let's go actually to that class and then see. So we have a size, so we are interested about the first position from each board row. I think this class should be called board column, not row, but it doesn't matter. Okay. Okay, so we need to get, we need to loop for int this is gonna be this dot length, and now we need to get the first element. So current game data at I row 0, and now we need to, so that is gonna be string. No, we don't need this board data then. We need to use this square list. If we have grid square data, so what is that? Sprite and no. So I will need to find where I actually spawned that bit. Square rect square list. That's right. Okay. So okay, so I think this is something I will need to do. So we need to find the selected So I think what we can do is basically use the index we have. So that's gonna be this. Because we're already passing the list with the index for the selected square and then with the column index. So the square list is basically continuous list of all of the squares. So by getting the right index, and then the column number. Okay, so I think we can modify this a bit. So I can grab this, I can put this here, Okay, that is the square per column, and I need to total columns, so okay, so that's this is gonna be start of the all of the index for that, and now we can get this for, and we need to look through the total columns. And for that we wanna do that I plus equal square per column. Okay, so, and we need to do just that. That's it. Okay, so we're gonna loop through total columns, and we're gonna add that bit, and then we're gonna get all of the columns. Right, so if I get this a bit of test, so F9, let's stop it and then start it again. So I got this, and then if I remove, I cannot remove anything from here. Okay, so this is spawn missing squares. Okay, so we have the total columns, which is 4, and then square per columns, which is 4, 1, 2, 3, 4. That's fine. So the first index will be 0. Oh, no. That's gonna be I times square per column. Okay, that is the correct version. Okay, once again. And now 1, 2, 3. So the first index will be 0. Then this will be 4, because we have 4 squares. So 0, 1, 2, 3, 4. That's fine. The next index will be 8, and the next index will be 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's right. So we have the correct index for all of the squares. And now what we can do is from the square list, we can loop through for each this index, and then we can grab our square list at top square index. So this is the column, and now we can create square at that position. So for the creation of the square, we can create the square, but the thing is, we're not gonna add it to the list because I need to introduce the object pooling So let's just copy it for now. Okay, there is something else. Okay, let's for now uh, 0. This is just so we have that square in. Doesn't really matter what picture we have displayed, and this data will change anyway. Get square index, so that's gonna be, let's get this to -1. Square scale, this is something probably we need to have. Right, okay, so this is the square. That's right, okay. And we need to get this spawn to position to be the square dot transform dot position, and that's gonna be, oh, we can actually instead of doing that, we can get this local scale. Okay, so theoretically we should spawn the rest those grid squares. So let's see if that's gonna work. So if I remove those 3, I think they are spawned, because as you see, the okay, I think what we can do is just to test, we first we're gonna spawn this, and then we're gonna remove the grid square, because I think what's happened is just taking the wrong index, and the square are already moved, so the position is not right. So if we first of all respawn them and then remove them, we have somewhere here, right, so this 1, 2, so it's definitely spawning something. Okay, let's try again. Okay. So we have this, and we have this spawned, and there is some issue. Oh, it's not total square, it's total square index, so that's the problem. Okay, so if I remove those 3, not sure if that's works, or let's get actually put this back. Okay, so we have this, and we have 3 new squares. I think we have 4 new squares. So yes, that's the problem is with this is basically we spawning the squares on every single column, which is here, on every single column. But what we need to do, we need to spawn this only if we have the column index from this. So if the list, the object, so let's call it data. If data dot contains maybe dot find we need to compare actually that bit. So anyway, for now I think I will leave it like that, because I do not have more time to do this right now. I think I've broken something as well. So yeah, I will leave it like that, and I will come back to this implementation probably today evening. I will just do another live stream with to carry on implementing this. So yeah, thanks for watching, and I will see you probably later today, if not probably tomorrow, to carry on with this project.